Hello guys, today we will discuss divisibility properties for all numbers started from 2 to 16. The easiest case is divisibility property by 2. If number x is divisible by 2, this means that this number is even, so this must be ended by 0, 2, 4, or 8, or 6 or 8. If the number is divisible by 3, then sum of the digits of x must be divisible by 3. So if we present x as an minus 1 and so on, these are digits. So this number can be expanded as 10 to the power of n times an plus 10 to the power of n minus 1 times an minus 1 plus da 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 all the way up to a0 times 10 to the power of a0 0. Clearly 10 equals to 1 mod 3, which clearly means that any power of 10 will give us 1 as a reminder when we divide by 3. So 10 to the power of k will be 1 mod 3. So instead of any power of 10, we can just substitute them by 1. This one will be 1, this one will be also 1, and so on. All of the powers will be 1. Clearly, this number will be equivalent of an plus an minus 1 plus all the way up to a0 mod 3. Which clearly means that if the sum of the digits is divisible by 3, our original number will be also a multiple of 3. Next case is if x is divisible by 4. Here the formula is that if we just need to look at last two digits. If the number made up by last two digits is multiple of 4, the whole number will be also multiple of 4. Once again, represent our number like this, an minus 1, and so on, a0. If you use the same expansion, last two terms will be 10 to the power of 1 times a1 plus 10 to the power of 0 times a0. And all other terms will be divisible by at least 10 squared. And as we know that number is divisible by 10 squared, this number is also divisible by 4, because 10 can be represented as 2 times 5. So it has no matter what numbers will be written before the last two terms, because they are always multiple of 4. So we just need to show that this number is multiple of 4. 10 to the power of 1 times a1 plus 10 to the power of 0 times a0, which is clearly a two-digit number, a1, a0. So if we prove that this number is multiple of 4, then original number will be also multiple of 4. Here we can see any example. For example, if we take 2024, this number is multiple of 4, and we can check that this is 506, and we can just look at the last two digits. 24 is multiple of 4, which clearly means that our number is also multiple of 4. Next number is easy case. Number x is divisible by 5 if number ends by 5 or 0. Because every multiple of 5 uh, will end by 5 if it is multiplied by odd number. So if we have 5 times k and k was odd, this will be ended by 5. And if we have 5 times even, 2 times t, this number will be ended by 0. Divisibility property for 6 is just composition of divisibility by 2 and 3. Composition divisible. Because, as we know that x is divisible by 6, this means that x is divisible by 2 and at the same time by 3. Which clearly means that this must be ended by even number, and sum of the digits must be a multiple of 3. Next number is 7, but 7 divisibility property is a bit hard one. In this case, we just need to take the last digit twice and look at the remaining number. If the remaining number is a, if a minus 2 times b is divisible by 7, this means that our original number will be also multiple of 7. But original number will be just 10 times a plus b. So we just need to show that this modular equation will be same. 10 times a plus b and a minus 2b will be same mod 7. So a plus b equivalent 0 mod 7. This must be equivalent of a minus 2b equals 0 mod 7. At first we can notice that 10 equals 3 mod 7. So this one can be changed as 3 times a plus b equals 0 mod 7. And if we multiply the second equation by 3, this will be equivalent of 3 times a minus 6 times b equals 0 mod 7. But clearly minus 6 equals plus 1. So instead of this equation, we can just write 3 times a plus b minus 7b equals 0 mod 7. And clearly, this will be correct as 7 times b is always multiple of 7. So we get that 3a plus b is 0 mod 7 if and only if 3a minus 6b is also a multiple of 7. And so we prove the 7 divisibility property that if we just take the last digit twice and subtract the remaining numbers erased by last digit, we will get the exact result. For example, we can check if we take 784 by using our formula, this number will be converted into 78 minus 2 times 4, which is exactly 70. And clearly 70 is divisible by 7. Similarly, we can check for any different number. Now, next number is 8. Number x is divisible by 8 if the number made up by the last 3 digits is multiple of 8. Here, the idea is very similar to the multiple of 2 and 4 cases because both of the numbers are multiples of 2, or powers of 2. So once again, represent an minus 1, and a0. And if we use the same expansion, we can see that we just need only last 3 digits. 10 squared times a2 plus 10 to the power of 1 times a1 plus 10 to the power of 0 times a0. In this case, all numbers which will have at least 3 power of 10, they are divisible by 8 because 10 to the power of 3 can be expressed as 2 cubed times 5 cubed. And clearly 2 cubed is divisible by 8. So we just need to look at only numbers which are made up by last 3 digits. And clearly the same idea will work for x equals 16 because this is also power of 2. But we will do this later. Once again, we can check that 1224, this number will be multiple of 8. So we just need to look at the last 3 digits. So 224 must be divisible by 8. And if we see the divisibility property, this will be 28. Next number which I want to discuss is 9. Number x is divisible by 9 if sum of the digits is multiple of 9. Here the idea is very similar to the idea discussed for divisibility property 3. Once again, we just expand 10 to the power of n times an, 10 to the power of 0 times a0. And in this case, once again, 10 equals 1 mod 9. which clearly means that any power of 10 will be 1 mod 9. From here, we can easily substitute each power of 10 by 1, and instead of them, we can just write once. And if we use modular arithmetic, this number will be equivalent of an plus an minus 1 plus an minus 2 all the way up to a0 mod 9. So if some of the digits is divisible by 9, our number will be also a multiple of 9. Here we can check one example. If we take 981, for example, we can see that some of the digits equals to 18, and this number is divisible by 9 because this is 109. And some of the digits is 18. Clearly, similar idea will work for every number. Next number in our row is 10, and I think this is the easiest divisibility property because number x is divisible by 10 if it ends by 0. And we can easily check this because any multiple of 10 times something, will be always ended by 0 because 10 is the number and we are considering every number in base 10. That's the reason why all of the numbers are ended by 0. Uh, Next number in our list is 11. Divisibility property for 11 is a bit hard because here we need to check odd indexed element sum and minus even indexed element sum. And if the given number will be multiple of 11, then original number will be also multiple of 11. If x was an minus 1 and a0, once again, this one expands as 10 to the n, an, and so on. 0 times 10 to the 0. And we can see that 10 equals minus 1 mod 11. 10 square, which is 100, 100 equals 1 mod 11. 10 cubed, which is 1000, this equals to negative 1 mod 11. 10 to the power of 4, which is 10,000, this will be equivalent of 1 mod 11. And we have 1s and minus 1s alternating, which clearly means that we can substitute these numbers by 1, not a0, 10 to the 0 can be substituted as 1, 10 can be substituted as minus 1, and so on. So this number will be given like a0 minus a1 plus a2 minus a3 all the way up to, we will have minus 1 to the power of n times an, which clearly means that some of the odd indexed elements minus even indexed digits must be multiple of 11 if we want our original number to be a multiple of 11. So clearly we can easily check this. If we have 121, in this case, as this is 11 times 11, but at the same time, sum of the odd indexed elements equals 2 and even indexed element also equals 2. And clearly this satisfies our property. If we want to find the divisibility property by 12, this is equivalent of using the divisibility property by 4 and 3 at the same time. Composition of 4 and 3. Because if the number is divisible by 12, this means that number is also a multiple of 4 and at the same time multiple of 3. So sum of the digits is multiple of 3, and last two digit number made up by last two digits, is multiple of 4. So a1, a0 number will be multiple of 4. Next number is 13. If x is divisible by 13, we have a bit ugly condition. This one is very similar to 7 divisibility property. Here we have uh, last 4 times last number plus the remaining number must be multiple of 13. A plus 4b must be multiple of 13, where b is last digit and a is the remaining digit, the remaining number. I erased b. And how can we check this? Original number can be written as 10 times a plus b, and we want to show that this is equivalent of 0 mod 13 if and only if a plus 4b is also multiple of multiple of 13. Okay, here we can take this equation 10 times. So this one can be written as 10 times a plus 40 times b. And clearly, 40 times b can be represented as 10 times a plus b plus 39b. And here we are using the fact that 39 is divisible by 13. So this number is equivalent of 10 times a plus b mod 13, which is exactly our original number. So from here, we can conclude that 10 times a plus b is divisible by 11, by 13, if and only if a plus 4b is also multiple of 13. Here we can check for the small cases, for example, 143. In this case, we can just take a, in our case, will be 14, and b will be 3. So a plus 4b will be 14 plus 4 times 3, which is 26. And clearly 26 is divisible by 13, which means that 143 will be also multiple of 13. Next number in our list is 14. Number x is divisible by 14 if number is even and also multiple of 7. So this is composition of 2 and 7 divisibility properties. So number is x is even, and if we take 7 divisibility property applied for x, we will exactly get number which will be multiple of 14. Next number in our list is 15. Number x is divisible by 15 if we apply the multiple of 3 condition and multiple of 5. So this one is composition of 3 and 5 divisibilities. So sum of the digits and must be ended by either 0 or 5. Sum of the digits is divisible by 3 or ended by, at the same time, this must be ended by 0 or 5. And the last number for today's video is 16. Number x is divisible by 16 if the number made up by last 4 digits of x is multiple of 16. Once again, if we consider an minus 1 and so on, a0, this one expands as 10 to the power of n times an, 10 to the power of n minus 1 times an minus 1 and so on, all the way up to a0. We can easily see that any power of 10 after 4 power is divisible by 16 because 10 to the power of 4 can be represented as 2 to the power of 4 times 5 to the power of 4. And here comes the idea that we just need to look at only last 4 digits, which will be 10 cubed times a3 plus 10 squared times a2 plus 10 times a1 plus a0. And clearly, if this number is divisible by 16, our original number will be divisible by 16, as we are only needing numbers which are multiples of 16. So this was all I wanted to discuss about divisibility properties. If you want to see more videos like this, please like and subscribe.